Okay, thank you. So yesterday we did the rotorcraft and the fixed wing. So what is the difference do you find between the rotorcraft and the fixed wing UAV? What difference do you find?
The rotorcraft would be vertical takeoff and landing, and then fixed wing will be, you'll have to, you need a runway, to glide on or
Correct.
land.
So that is one of the advantage and disadvantage of it. So advantage of rotorcraft is that you can take it from a small space, vertically take off and land. Whereas for fixed wing, you need a runway, or probably if the device or the aircraft is small, then probably you need catapult, or you can use the hand to throw it in the air also. Okay. Uh, how about the endurance in both of them? Or the flight time, what we say?
The fixed wing will have a larger flight time, I think. It will glide in the air.
Right. So again, depending upon the engine what we are using. So normally in a larger fixed wing, you will have an internal combustion engine, which will allow you to fly the fixed wing for more amount of flight time. So it could be depending upon the fuel tank capacity. Okay, so depending upon how much fuel is available or fuel is there, it can fly maybe for 1 hour, 2 hours, 8 hours, 24 hours, 48 hours. So we have seen fixed wing with internal combustion engine flying up to 48 hours also continuously. Okay, whereas the rotorcraft, since it is powered by only batteries, either lipo or lithium ion, they can only fly maximum like 15, 20, 30, 40, 60 minutes. There I have seen at least drones somewhere around 60 minutes, 60, 70, 80, 90 minutes also I have seen. So not more than that. So that's the limitation of the rotorcraft. Okay, and the advantage of the fixed wing is that they can fly for longer flight durations, or endurance capacity is more. Another comparison I could talk about is the hovering capability of the rotorcraft. Okay, so at a one particular location you can lock and you can make drone fixed flying at one particular location, whereas the fixed wing cannot be fixed to one particular location. It has to be continuously in forward motion. Okay. Another disadvantage I would talk about the rotorcraft is that in failure of a single motor, it cannot sustain. Okay, so it will crash. Whereas in case of any issues related to power driven motors or anything like that, still your fixed wing can safely glide and land successfully on the land. So that is one of the advantage of the fixed wing over the rotorcraft. Okay, so both has their own pros and cons, and hybrid drone is nothing but is the combination of the fixed wing and the rotorcraft. Okay, so the whatever the best options you have in both of the categories are being put into and used it as a hybrid. Okay, so it is a combination of your fixed wing plus your rotorcraft. Okay, so that is about your hybrid. It is also called as VTOL. Okay, so normally people lot of get confused between rotorcraft and hybrid. So both are actually a VTOL, but for rotorcraft we don't call it as VTOL because it's not like an aeroplane. Okay, rotorcraft is I always vertical takeoff and landing. But hybrid is like a aeroplane which can take vertically, take off and land vertically. Okay, that's why it is called VTOL. That is vertical takeoff and landing of aeroplane. Okay, that's why it is called hybrid. So in hybrid also, since the fixed wing components are there, so we need to understand what is the principles of aerodynamics, then types of hybrid drones and parts, and then applications of hybrid UAVs. When which area or what segment of terrain normally you use hybrid, in which locations you will normally use hybrid UAVs. So again, since it's the same functionality what is being used in a fixed wing, hybrid also has its own fixed wing. So four forces acting on a drone, that is lift, weight, thrust and drag. Airflow changes and pressure distribution over the airfoil. Since it's a fixed wing structure itself, so normally you will always see the same concept of aerodynamics applied to the hybrid drone also. Okay, so here again we talk about the airfoil. You see there is a leading edge, trailing edge, straight line between the leading edge and the trailing edge is a chord line. We didn't talk about the camber line in the earlier discussions, but here we are talking about camber line. Camber line is a equal line joining the leading edge and trailing edge, equidistance from upper and lower surface. If you see the distance from the upper surface and the lower surface, camber line will always at any given point in time, wherever you see, if you see here also, the distance between the upper surface to the camber line and the below surface is always equal. So it is equidistance from the upper and the lower surface at any given point. Okay, wherever you see on this yellow line, it will be equidistant from upper surface and the lower surface. Whereas chord line is a straight line from leading edge to trailing edge. Okay, so it is basically the camber line defines the shape of the aerofoil. Okay, whereas chord line is just a reference line to understand the with respect to the angle of attack. Okay, so chord is a distance between leading and the trailing edge measured along the chord line. Okay, the maximum thickness is the maximum distance of the lower surface from the upper surface. Okay, so that's the maximum thickness you will of the airfoil, you will see it at the somewhere here. Okay, as you go towards the leading edge, the thickness will reduce, or even you go towards the trailing edge, your thickness of the airfoil will reduce. The maximum thickness where will be somewhere here in between. Okay, where it is a maximum distance from camber line to the upper surface to the below surface, that will be your maximum thickness. Okay, the force acting on hybrid drone, since it's like an aeroplane only, so lift is the force that holds a drone in the air. Wing creates most of the lift used by the aeroplane. So normally in hybrid operations, it is only the vertical takeoff and landing is done. Okay, whereas the operations are always carried out as a fixed wing. Okay, weight is the force caused by the gravity. Thrust is the force that moves aircraft in the direction of the motion. It is created with a propeller. It can be propeller with jet engine or rocket. Air is pulled in and then pushed out in an opposite direction. One example is the household fan. So now normally you see in household fan, when it moves, you will create the push of the air. The drag is the force that acts opposite to the direction of the motion. It tends to slow an object. Drag is caused by the friction. Okay, so since there is a body structure going against the air, okay, so there is a difference in the air, pressure is created, friction is getting created. That's why you have a drag. So in any given point in time, any device which is moving around in the air will never have drag as zero. There will be, whatever way you design any aircraft, there will be some other drag will be there. Okay, for example, if you like when you are traveling, okay, in a car or a bus, you just take a hand outside. Okay, you take a hand outside, you will feel the air. Okay, you just tilt little bit, you can see the pressure and your hand will try to go up. Okay, so this is Bernoulli principle, because there is a pressure difference is getting created, your hand will go up. But if you make the hand completely perpendicular to the ground, what happens? It doesn't go up, it goes backward. So this is a drag. Okay, just give me a minute. Huh? So Rohit, we just started. We were just talking about couple of slides, okay, about the hybrid drones. So we just talked about uh, hybrid drone operations and aerodynamics, principles of aerodynamics,
Okay, sir.
types of hybrid drones and parts, and then we'll talk about applications. So we just were revising since it's a similar to your fixed wing. Okay, so
Okay.
lift, weight, thrust, and drag. So airflow changes and pressure distribution over the airfoil. So similar to our fixed wing, we have here also, since it's a fixed wing structure only. So airfoil functionality will work over here. So leading edge, trailing edge, chord line, camber line is something what is introduced here. It's a line adjoining the leading and trailing edge of airfoil with equidistance from upper surface. If you see the yellow line, it is equidistant. Any given point in at the airfoil, you will see it is equidistant from the upper surface to the lower surface.
Okay.
So we were talking about the forces acting on the hybrid drones. So lift, as we know, lift is the force that holds the drone in the air. Wing creates most of the lift used by the airplanes. Weight is the force caused by the gravity. So any aircraft will always have a weight. Similarly, thrust is generated by the engine. Either it could be a battery powered engine or it could be a IC combustion engines, depending upon the size of the hybrid drone. Drag will be always there because drag is the creating because of the friction and the difference in the air pressure as the aircraft is moving in the air or in the atmosphere. So drag is the force that acts opposite to the direction of the motion. It tends to slow. So you have to aerodynamically design your aircraft so that your aircraft can function perfectly in the motion when it is in forward motion. For example, I was given an example about like when you are traveling, normally you put a hand outside of your car or a bus. Okay, normally you are having a parallel to the ground. You will just feel the air. But as you tilt your hand little bit, you can feel the pressure. There will be air pressure difference, and your hand will tend to go up. Okay, but if you make it perpendicular, it will not go up. So this is more drag. So here the drag is there, but very less drag is there. It will try to go up. But if you make it perpendicular, your drag is almost 100%. So your hand will not go up, but it will go backward directions. Okay, so it will feel back. You will pull full back. So that is how you feel the drag. Okay, that's why aeroplanes or even cars are being designed aerodynamically so that they effectively give you better performance, better efficiency when they are driving or flying at a high speeds. Okay, so let's see the parts of the hybrid drone. So now hybrid drone is similar to your fixed wing. So you will have a wing. Okay, wing will have the ailerons which covers or makes your roll motions which are responsible for roll motions. Then you will have a vertical tail and a horizontal tail. Horizontal tail will have an elevator which will control your pitch motions up and down, whereas vertical will have a rudder, so which will responsible for your yaw motion or your directional motion. Okay, normally the heading of the aeroplane or the drone will be normally changed by vertical stabilizer or vertical tail, that is having rudder. So similar to quadcopter, you will see four motors. These four motors are called nothing but lifting motors. So it will vertically take off. The hybrid drone will vertically take off, then it will transition and become a aeroplane and then fly in forward motion. So you see there is a fifth motor. Okay, so there is a motor behind the fuselage. That's why it is called a pusher motor. If the motor was in the front of the fuselage or on the front part on the nose section, then it would have been called as a puller motor. So depending on the position of the motor, okay, since here the motor is at the back side of the fuselage, that's why it is called pusher motor. If the motor was here in the nose, then it would have called as puller motor. So depending upon how the fixed wing and the rotorcraft is been designed over here in a combination, the hybrid drone will be called as either pusher motor or a puller motor. And the four motors, these four motors are nothing but these are just for takeoff and landing. So they will be only active during takeoff and landing process. Once it transitions from the rotorcraft drone to the fixed wing drone, that point in time, accordingly, the motors will function. So during their normal operations, the pusher motor will be active, whereas during takeoff and landing, only the lifting motors will be in action. Okay. So this is the different configuration. There are drones configured in such a way the same motors can be also used for vertical takeoff as well as horizontal flight also. So if you see here, the motors are actually perpendicular to the ground, so this will let it do the vertical takeoff. As it goes up in the air, the motor angle of the motor will change and they will become horizontal, and that's where actually the horizontal flight will start. So normally during this phase of motion, probably your back motors will be stopped, only the front two motors will be working, and your drone will be always in a horizontal flight or horizontal motion. Once it has completed its mission or activity, again there will be a transition maneuver will happen. Again the angle of the motors will change and it will become vertical, and then it do the vertical landing. So that's how the configuration of hybrid drones works. Some have fixed wings on fixed motors also, like we saw in the earlier example, right? Here we have a separate motors for takeoff and landing, where is a separate motor for horizontal flight. Okay, in this case, the same motors are being used for both functions. For vertical and takeoff, you are using the same motor. The angle of the motor is getting changed. Even there are some hybrid drones are configured in such a way their wings also get changed. Okay, like they have a wings, both get becomes vertical also, and they become parallel also to the fuselage. Okay, so depending upon the configuration, the design has been done. That's how they use the best of the both options, whether it is a rotorcraft or fixed wings. The best of the both type of the drones is being used so that they get a optimal performance during the activity. Okay, so these are different types of hybrid drones. You can see here the first example what I've used, the 5 motors. Then you have a drone which can change the angle of the motors or the engines depending upon the functionality. When it is to take off vertically, then the motors will be vertical position. When it is in horizontal flight, the motors will be in a horizontal position. Whereas this is a drone which is a fixed wing. Here actually drone itself changes. So this is the type of the drone which I am designing for the Rajasthan, one of the OEMs in Rajasthan, where we are actually designing a fixed wing. This is almost similar type of that we are designing with the same, almost same configuration. Okay, more or less same configuration, but the length, I mean, if you see the fuselage here is just little bit smaller, or fuselage is little bit longer, okay, compared to the wing size. So this size of this wing is almost 4 meters. Okay, size of this wing is almost 4 meters. Any questions so far on the types of hybrid drones? Or we are good? So what are the applications of hybrid VTOLs? Hybrid VTOLs are used where the terrain is difficult for landing a fixed wing aeroplane, like because sometimes like areas like Assam, Kerala, where you have lot of slopy areas. Okay, terrain is not a plain terrain, where you have a difficulty to make a runway and all those things available. In that scenario, but we want to fly a fixed wing. Okay, because we need to cover a large area. There we need to fly the fixed wing, but we cannot have a runway over there. So in these scenarios, we will normally use hybrid VTOLs. Okay, so there where we have to do large area mapping or transport heavy payload over a large distance with the hilly terrains like Ladakh or probably Assam, Kerala. These type of locations normally people use hybrid VTOLs. Okay, or even in search and rescue, where you have to quickly take off your aircraft and you have to scan the large area and all the things. In that scenario, you will use hybrid VTOLs. Even for cargo deliveries, like as I said, hybrid VTOLs are also been planned to use in like Ladakh region, where they have to deliver cargoes for the military bases and all the things. So earlier those cargoes were delivered using helicopters, but now since flying the helicopters in those regions also is very difficult and all the things, so drones are being now planned to be extensively used for such kind of activities and such kind of deliveries. Okay, where you don't require or don't have to risk human lives over there. Okay, so with that we complete the hybrid topic, hybrid operations and aerodynamics. Okay, so there is a separate certifications also can be done, or separate license can be also can be generated using the hybrid when you get a training on hybrid operations and dynamic. So there are only 2 locations where you get trained on the hybrid drones. Okay, but they are still not commercially, or commercially they are still not being used. Mostly the hybrid operations are being performed by the defense only. Okay, they have not been in a civil aviation or this thing. They have not been very extensively used as of now. Okay, that is the reason why, because if you see hybrid, okay, the VTOL will need, if you have a VTOL like this, okay, this still it takes a lot of space. That's why we are not using this type of configuration. When I'm working with one of the organization, I'm trying to design this type of hybrid drone. Okay, so it will land vertically, it will take off vertically, and then it will just change its orientation and fly horizontally. So this is very efficient, power efficient design for a hybrid type of drone. Okay, so this basically we are designing for surveying kind of drone. Okay, not for cargo delivery and thing, but this is for surveying drone. Okay, so with that we complete our topic on the hybrid operations and aerodynamics. So we complete the day one topics actually. Now we have completed our day one. We'll start with our day two topic.